Okay, in this video, I'm going to show you how to add a dummy variable and how to take the log of your year variable, and how to include these two new data or column, two new column into your regression. Okay, so I have this is the continuation of the third video, so this is the fourth video on the price dependent keeper equation. My first column is still year. I include my real price of my major commodity, which is chicken. I include my per capita consumption of chicken and my real per capita income of chicken, because these two variables show statistically significant impact on the real price change of chicken. So this is this estimation we have already learned in my previous video. So now I'm going to add one new column, and I call this column dummy. So I call it dummy of per capita consumption of chicken variable. Oh no. So it's going to be dummy of real price. I'm sorry, real price of chicken. Real price of chicken. So now I'm creating a dummy for my real price of chicken variable, and I would just decided to allocate 0 for any data that is before 1996, and I'm just going to add a 1 that is after 1996. So I am I'm adding a new column, and I've really just to decide to separate my dependent variable into two different groups. So now with this new column added, I am going to run a new estimation to see if these two groups, the first group is any real price that is before 1996, and the second group is any real price of chicken that is after 1997, and I'll see if these two groups are very different in terms of the value. So what I do is to go click data analysis, check regression, click OK, and my dependent variable is the same. That's going to be the real price of chicken, including the title, and my explanatory variable input X range. I'm going to include my per capita consumption of chicken, real per capita income, and my dummy column in my estimation. Just select these three columns. I'm going to click output range, and I'm just going to put my output, let me just put it somewhere on the right hand side. Just going to put it right in here. Just click this, and I'm going to click OK. So now we have received the estimated result in here. So check my R-square, which is much below 80%. So I got to go to my F-stat, which is about 5. So I'm going to stop here. I know my model is valid. So I'm going to go to check my result of my included coefficient, my included variables. So my t-stat is absolute value of my t-stat is bigger than 2 for per capita consumption of chicken. P-value is less than 10%, so I still conclude my per capita consumption of chicken has a statistically significant relationship with the real price change of chicken. My real per capita income has a high t-stat and a low p-value, so I can conclude my real per capita income has a significant and positive impact on the change of real price of chicken. And now if we look at my dummy variable, that I got a low t-stat and a high p-value. P is much bigger than 10% and t is much smaller than 2. So in this case, I am going to conclude that my dummy variable that I created is not significant. Well, I can see that the two groups that I assigned, they're not different in terms of the real price. So in terms of the real price, these two groups are not significantly different from each other. So that's how I interpret my result for my 3 estimate, especially my dummy variable. Dummy variable is not statistically significant. So in my final model, I don't need to include this dummy variable column. And now let's include one more column, and I call it log year. So let's create this log year. The reason I want to include this log year is I wanted to find out if the real price of chicken would change across year or not. So to form the log year, I'm going to click equal, put log, or I just put ln, left parenthesis, include my 1985 in there, right parenthesis, and click enter. For the second one, equal ln, left parenthesis, my second year variable, right parenthesis, click enter. So that's how I take the log of my year value. So I can just drag it down to fill the rest of the spreadsheet. So now I have formed a new variable, which is a log year. So now I'm going to run a new regression. I'm going to click data analysis, check regression, click OK. My Y range is still my real per price of chicken, and now my X range, that would include my per capita consumption of chicken, real per capita income, dummy of variable of chicken, and the log year. So let's just see what will happen with including this log year. And I want my output to be printed right here, and I'm not going to include my residual. Check it off, and I click OK. I'm going to overwrite the existing data. Let's see what is the result look like. Again, check my R below 80%. Go to my F. My F is about 5, so I am confident my estimation is valid. So let's check the t-stat and p-value. I got a significant per capita consumption of chicken variable, a significant real per capita consumption, per capita income variable. See, the t-value is less than 2, but if you check the p-value, it is less than 0.1. And my dummy variable is not significant. And let's check the log year. This variable again is not significant. So I can conclude my real price of chicken does not change, does not have a significant change across years. So in my final variable, I'm not going to include the dummy and the log year. I'm going to include my per capita consumption of chicken and my real per capita income of chicken. Only these two variables as my explanatory variable or independent variable in my estimation. Okay, thank you.